The International Space Station, or ISS, orbits the Earth at an average altitude of about 400 kilometers, traveling at a speed of 28,000 kilometers per hour. The construction of the ISS began in 1998, with modules and components launched and assembled over several years by space agencies around the world. Here, we see the first module, Zarya, launched by Russia in November 1998. It provided essential power and propulsion capabilities. Shortly after, the Unity module, launched by NASA, connected to Zarya, marking the first major international collaboration in space. The ISS grew with the addition of the Zvezda service module, which provided life support systems, living quarters, and command control for the station. The Destiny Laboratory module, launched by NASA, was added next. This US lab module became a hub for scientific research in microgravity. The Quest Joint Airlock, also from NASA, enabled spacewalks and maintenance work outside the station, enhancing its operational capabilities. The ISS continued to expand with modules like the European Space Agency's Columbus Laboratory, contributing to scientific experiments and research. Russia added the Pers docking compartment, which facilitated docking and provided additional space for conducting experiments. The Japanese Kibo Laboratory, the largest module of the ISS, offered a unique platform for a wide range of scientific investigations. The Harmony module, a connecting node, integrated various labs and expanded the station's living and working space. Tranquility, another node module, provided additional life support and environmental control systems, enhancing the habitability of the ISS. A key addition was the Cupola, a dome-shaped module with windows, offering unparalleled views of Earth and aiding in station operations. The ISS also includes external trusses and solar arrays, essential for power generation and structural support. These solar arrays generate electricity from sunlight, powering the station's systems and scientific instruments. Robotic arms like Canadarm2 and Dextra play a crucial role in assembling modules and performing maintenance tasks. International cooperation has been key, with contributions from NASA, Roscosmos, ESA, JAXA, and CSA, among others. The ISS serves as a testament to what humanity can achieve through collaboration, pushing the boundaries of science and exploration. It remains a platform for scientific research, technology development, and international cooperation in space. The ISS continues to inspire future generations, paving the way for deeper space exploration. We hope this glimpse into its construction has enlightened you on the complexities and wonders of space engineering. Stay curious and keep exploring the mysteries of the universe.